Hello and welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, today we are looking at a brief history of CAD.
Is that what we're calling it today?
I mean, it's a history of CAD. So.
I did just type it, so...
You should know then.
I should.
So I thought to kick things off in a very exciting fashion...
Woohoo!
I like that. Woohoo!
It's kind of like my poo voice.
The Pillsbury Doughboy?
Pillsbury.
Pillsbury. Anyways, we take a look at some
moving.
terms that you might need to know.
Okay.
Such as CAD. Luke, what does CAD stand for?
So, do you want like the double D CAD or the single D CAD?
I certainly want the double D CAD.
Okay, so that was totally unintentional. So, it used to be CADD. You probably don't know this because of how young you are and
That's
you don't
true.
shave yet. But CADD was computer-aided design and drafting. So that's why they were
Computer-aided design and drafting.
So that's why it was 2 Ds. And I'm guessing maybe 20 years ago, 15 years ago, the drafting for some reason or another dropped off. And
because people quit doing drafting?
Well, I don't know why. There probably wasn't a really great reason.
Okay.
Maybe it was too long to spell or something. But now it's computer-aided design. So
Computer-aided
just CAD.
design.
Yeah,
okay.
Correct.
That makes good sense to me. Now, I thought I'd also throw out there CAM. And I know we talked about CAM as well. And it isn't really CAD, but you know, there's a lot of CAD CAM packages out there.
They definitely go hand in hand, for sure.
They do. So we got some computer-aided machining I'm going to go with on that one.
Machining?
Well,
yeah, machining. I was thinking manufacturing. It's different.
What about CAE? There's a lot of CAs going on today.
I'm not sure I got CAE.
Computer-aided engineering.
Oh, so that's a simulation analysis, that sort of stuff.
It's kind of like, I like to think of it as like the whole pizza pie.
Oh, so bigger than just simulation. That's
More,
everything.
it's everything. It's the design. It's the simulation. It's the product life cycle.
So
all of that good stuff. Kicking it up a notch.
You say CAE is like the high level.
I think so.
Of everything.
I've heard people say CAX, but that's stupid.
X
is kind of like the X factor.
Oh,
I
it
think,
could be anything.
Which is stupid. That's what we call that.
Wow, I feel like you have an opinion on this.
Yeah, I usually do. I'll throw out a few more. IGES, IGES. So it's a file format.
I know. I don't know what it stands for though.
I never knew this either. It's the Initial Graphics Exchange Specifications.
So like whenever we're working in, Pro E or Inventor or SolidWorks, oh, give me an IGES file.
Give me an IGES. It's like a dumbed down, solid,
neutral
file format.
Gotcha.
Right. NURBS, do you know that one?
Those are people I used to pick on in high school.
That's different.
Oh, I take that back.
That's me.
I used to get picked on because I was a nerd.
Right. Non-uniform rational basis spline.
So this is what creates the 3D geometry.
It represents a curve or a surface or something.
I
don't want you to get the last one. The last one's my favorite. Do you know what ACIS stands for? ACIS.
Those are the tennis shoes that runners wear.
Andy,
no, that's ASICS. Sorry.
Andy Charles Ian's system.
No, it does not.
Right? How awesome is that?
You just did bad research.
No,
that can't be accurate.
It was developed by Spatial Corporation, now part of Dassault Systems.
That cannot be accurate.
Yeah, no, I actually looked it up on a number of different places because I said the same thing. Like somebody's messing with us here.
I could have swore it was something else.
All right, so I think that's everything we need to know. So
I think it is too.
Let's go. Well, maybe not everything.
I had one for you.
Okay.
I had one for you. What was it? When we were talking at the beginning. Oh, kernels. Do you know what kernels are?
No, like the popcorn things.
No, not
Parasolid.
You're right on it.
And
ASIS is actually
the other one.
kernel.
Yeah, those are like the two biggies,
the two
right?
biggies. So what a kernel is it's the engine that actually drives what shows up on your screen. So so now that we're obviously for years and years and years we're doing this graphical user interface with CAD. It's not just you plug it in and it punches out numbers like way back in the early days. You actually see what's happening on the screen. And the kernel, James, is why none of these software packages talk well together.
Oh, that's nice. So they're actually the enemy.
What the kernel, because they all use different kernels. So Autodesk uses a kernel for their 3D software, and PTC uses a kernel for their software, and SolidWorks.
And I assume SolidWorks uses ASIS as they own it.
I'm almost positive they do. But that's what causes the problems with interoperability between different CAD systems. And there's all types of ways to get back and forth, and all the different major CAD systems today have interoperability tools that allow you to go back and forth, but the kernel is the problem.
Very good. Well, before we get into these CAD tools, and since you're so much older and wiser than me, I thought maybe you would want to talk about life before the computer.
Yeah, so have you ever done a board drafting class?
Yes, in 10th grade. So
one class,
10th grade, and it was only it was a semester at most. It might have been 9 weeks.
Wow, that's
and it also included basic AutoCAD as well.
Okay.
So only part of the time was I hand drawing things.
Okay. That's interesting to hear. Okay, so obviously CAD's been around forever, and board drafting has been around even longer than that. But where this all really started was back in like the 1500s.
What?
So, well, not CAD, but so design was something where people would just put stuff together physically. They would just make stuff. Right. So these were the original makers. The original hipsters were happening back in like Leonardo da Vinci's time, right?
He was the first hipster?
Basically.
Did he wear skinny jeans?
I'm sure he did. A skinny robe.
Skinny.
You like that?
Yeah, that's good.
But like Leonardo da Vinci was one of the first to start documenting what he made, and it was more artistic than it was an actual, what we think of when we think of a 2D drawing.
So it might not have been an accurate representation of what he was doing,
probably
more
wasn't
so
to scale.
Artistic.
It wasn't to scale, it was probably more artistic. And what happened over the 18th and 19th century was, number one, probably the biggest one, and this was like early 18th, 19th century, was the development of a scale.
Okay.
And you know what a scale is versus
like
a ruler,
a 1 to 1 or a 1 to 2 or a 2 to 1 scale.
I always tell my daughter, a ruler runs a country, and a scale is what you use to measure something.
Wow.
So whenever your teacher tells you to get your rulers out, it's not a ruler, it's a scale.
Okay, then.
So scale was probably the biggest thing that was really.
You're such a dad. I'm sorry.
So scale was probably one of the biggest things, so that you could very easily and uniformly make things repeatedly. You could draw things that are very large at a very small scale. So that was probably like mid 18th century where the consistent use of a scale. And then obviously since then, different drafting standards have been developed. It has gone from using ink to using graphite to using, mechanical pencils. I know that I have done a ton of board drafting, obviously through high school, college. One of my first jobs,
really?
I was doing.
You had a job doing drafting, hand drafting?
So we didn't do so I think what happened my first job was around 94-5 time frame. I don't remember the exact date.
Wow.
And there was CAD definitely existed, because CAD was like late 80s is whenever like AutoCAD and MicroStation was around. What we would do is we would update board drawings and paper drawings. We would update them, but if we did brand new designs, we would take those designs and do those in AutoCAD or MicroStation.
Okay.
But if we were changing an existing one, that's
you would
when
update it with pencil.
So we would erase
That's so stupid.
And we would do like layers to.
You guys were not planning ahead very well.
No, we were not planning ahead very well.
Okay.
So T-squares, and then there was the mechanical drafting device, I think it was called, the MDD. So if you know that, it has that little round thing on the left, and it had a little articulator on it, so you could very easily draw really repeatable horizontal and vertical lines or angular lines, and it actually attached to the drafting board. And you had to zero your drafting board and you put your paper on. Did you ever have to do that?
No.
So you put your paper on and you put your T-square or your MDD on, and you draw your straight line, and that's your zero
This all
line.
sounds terrible. Can we get into some form of technology, please? This is horrific.
Yes, we can. So I have a question for you. When do you think, what year, and hopefully you don't know this, what was the year I think most people attribute the initiation of
1957.
You are the worst.
Oh, I am the worst.
Do you know what it was called?
Mr. Patrick Hanratty. Can Ratty? Is that his name?
He's got a rough name.
Yeah, he's credited as the father of CAD, right?
Do you know what school he went to?
He went to, I'm guessing, MIT.
Yeah.
What, did he really?
He did. He went to MIT.
But he was working for GE when he did this, right?
He did. And
smart guy.
the cool thing is, do you know what the name of the software was that he made, or the software tool?
I do, but I'm going to let you go for it.
Sketchpad.
Yeah. Wait, Sketchpad?
Yeah.
Are you sure? No, you're making this up.
That's
You were
what I
terrible
have.
at research.
It's Sketchpad.
Let me run through this for you.
Oh, you're the
He
worst.
developed Pronto, Program for Numerical Tooling Operations,
I got
CNC.
that. Yeah.
Ivan Sutherland, our boy from MIT.
Okay, I would. Okay.
There you go. Now you can go with Sketchpad. Go ahead.
Okay. Sketchpad.
Sketchpad. Was that it?
It was. Sorry.
Okay.
Yeah, that's all I had.
A man-machine graphical communication system.
Now, the crazy thing about these systems back then is they weren't real-time interactive.
Okay.
So what would happen with these is you would actually plug in whatever numbers you want, whatever design you wanted, and then you had to wait to then see the results of the calculations.
Okay.
And then you would see what that drawing would look like.
You have to be very confident.
You do.
They do not model the way I do.
Not at all.
Okay.
With no confidence?
With no ability.
I wasn't going to go there.
Thanks. All right, so what do you have next in our brief history of CAD?
Okay.
Now that we got the basics done and we know who developed these things, or at least I do.
So I focused in on kind of the big CAD players, I'll say.
Okay.
And I have a couple of dates, and don't look at my screen.
Okay.
So
Can I look at my notes?
You can look at your notes if you have them.
If I have them.
The first one is MicroStation.
MicroStation. Let's see.
What year was the first release of Bentley's MicroStation?
Bentley's. I do have that listed on here somewhere. That Bentley owns MicroStation.
1985.
85. See, you're already past all of my years that I've started with.
Oh,
But
you
go
started
ahead.
before that?
Would you like me to go through what I have? It's not really very interesting.
So do before 85, and then we'll go from there.
In the 70s, research started moving on, and Ken, somebody or other, started inventing NURBS. I can't pronounce his name. Versprili. I don't know how to say this.
You're better off not saying it. You're
See,
right.
this is what you did. All these people are doing thesis work, by the way. Mr. MIT before was
So they're
doing
not,
it.
yeah,
This
so
guy's
these,
doing.
These are production systems. I thought we were talking about
Well, this is when
production
NURBS
systems.
showed up, and this is
Okay.
kind of like laying the groundwork for all of these for-profit companies running the software. So then, with the emergence of the UNIX system in the 80s, commercial CAD systems like MicroStation and CATIA began to show up. And they were primarily used in like aerospace, automotive, and other large, very lucrative, we'll say, or well-off
they
industries.
Charged a ton
Yeah,
for
because
these
they were
things.
the only ones who could really afford this
So that was
sort
what
of stuff.
the Unix
That's like-
was 1982, right?
That was early 80s, right?
Okay.
And so, see, that was all I had before MicroStation.
So you didn't have much.
No, I told you I didn't have much, and that it wasn't very interesting. So
That wasn't
Well,
interesting at all.
I do have the introduction of the first IBM PC in '81 set the stage for large-scale CAD adoption. And I think
Okay.
the word large scale or the phrase large scale is kind of relative there, as anything I saw, it was still pretty much the big players could afford this stuff.
Yeah, I'm with you.
But that's okay. And then before MicroStation as well, and this is kind of some fun facts, especially for us,
I love fun facts.
a group of programmers formed Autodesk in 1983. 1983. That was a long time ago. And released AutoCAD.
Do you know what year the AutoCAD was? What year was that? The
83 is what I have.
I have 82, but
Okay,
I
well,
think
give
our
or take.
research is probably
Yeah.
give or take.
So this was the first significant CAD program for the IBM PC. And in 83, Autodesk sold nearly 1,000 copies of AutoCAD for a whopping almost $1 million. That's pretty impressive. By 86, Autodesk was doing over $50 million in annual revenue.
That's pretty impressive.
That's pretty good.
Especially with just a 2D
2D
drafting.
junker of a tool, right?
Well, I mean, I wouldn't say junker. I mean, it was at the time. This thing was like cutting edge.
is.
You
It was.
realize so. to talk about that AutoCAD transition time frame, so before you could get onto like an IBM computer, so something that was roughly the size of like a bread box, right?
Yeah, right.
So they had these things, and you probably have heard the word before, called a mainframe.
Never heard of it.
Never heard of a mainframe? Okay, so basically IBM back in like 1972 had these mainframe computers. They were the VM/CMS mainframe operating systems.
Okay.
And it stood for virtual machine, which is kind of crazy because we use these terms today still, and conversional monitor systems. And these would be doing large batch processing. It still wasn't very graphical.
Oh, so it's not like I draw a rectangle, it shows up, and then I edit that. It's you hope for the best still.
Yeah, you're still programming the computer. Then finally, so in 1977, this is whenever they call them mini computers, which is so humorous. Because when I think of a mini computer, I'm thinking of like a Raspberry Pi, right?
Yeah.
Like this little thing that fits in my pocket. But these mini computers were literally like the size of like rooms and like desks, and like you would have to have like dollies to take these things in and out of. And this is whenever real-time computing started to happen. So like when you were actually doing the programming, you could begin to see what was happening on the screen. Still not to that mass market, still ultra high-end, ultra big companies using it. But these were mini computers. So then finally, you mentioned the Unigraphics workstations. So that was Sun Microsystems 82.
Oh, okay. I wonder if Sun still makes computers. I know they did when I was in college, but I don't know if they still do.
I remember I was doing some work for Bombardier. They're the people that make the people movers and like trolley systems.
They don't make that bubbling, sparkling water?
No.
That's someone else.
We worked on, when I was there, we used these big, huge Sun microsystems, and they were enormous. And
they were big, huge, and enormous.
And we were using computer vision.
Wow.
And this was back in like 93, 4, 5 time frame. It was crazy.
Wow. I'm going to interrupt you before you finish your thought. I think we need a word from our sponsor.
I think we have a good week this week, don't we?
We do. So
not that we have a sponsor.
I was going to
this
say,
week.
Since last week you told me I'm no longer allowed to just make up a sponsor because apparently they frown on that.
Yeah, I think that's illegal.
I am going to give a shout out to a number of people. So brace yourselves.
Oh, here we go.
This is a record-setting week. Jim F, Steve F, Jeff H, Pete M, and the guy from CAD Noobs, which I think is very fitting.
Yeah, I like
all
CAD
reached
Noobs.
out to us this week. If you haven't checked out the CAD Noob podcast, go do that.
Yeah.
If you like this one, they're even nerdier and get into actual details on how to use CAD.
I think they're much better than we are too.
Probably better looking, but I don't know if they're better at this. So what's that? 1, 2, 3, 4, 5-ish people reached out to us. Well, CAD Noobs is 2 people, so 5.5. So that's awesome. We're on a roll. So
is that what we call this, a roll?
Sure. So with that, if you subscribe to Unprofessional Engineering, email us some proof of that at unprofessionalengineering@gmail.com, and we will send you some amazing Unprofessional Engineering stickers. You probably don't even really need to show us that much proof because you seem like honest people. You listen to us after all.
Oh, you're very honest people for sure.
So I guess that's about all I have. Email us. We'll give you stickers. And thanks for reaching out to us, everyone that did so.
Do we want to mention like our upcoming our one upcoming event, or do you want to save that for the end?
Let's save it for the end.
Okay, perfect.
All right. Back to your thoughts.
Okay, back to my thoughts. So, so personal computers was around 1995. So that's whenever Microsoft launched Windows 95. So this is whenever it actually became like a computer that like, and these were still crazy expensive computers, by the way.
In 95?
Yeah.
Okay.
So 95, how old were you?
13.
Okay.
How old were you?
That's horrible.
Let's not worry about it. Okay. Yeah, I was 13. And I bet that's about when we got our first computer at home.
Yeah. That sounds about right. Okay, so now we're kind of all caught up to right around the 8. Okay, so we did MicroStation was 1985. AutoCAD we said was 1982,
82, 83.
So those were the two I would say, heavy hitters in 2D. Computer vision was around, and there were some other, but it was basically MicroStation, AutoCAD, and computer vision were the big 2D players in CAD.
Okay.
And what do you think happened? Don't look at my screen. In 1987.
I bet a very difficult to use 3D CAD modeling system called Pro Engineer showed up on the scene.
Yeah, so
Man, we are good at this.
we are very
We
good at
are
this.
on top of things this
So
week.
in 1987,
Hold on. Have you used Pro-E before? Any form? Wildfire, Creo,
I
any of it?
used, I think it was like 19 or 20, because they're and all software companies do this.
yeah.
They change the way they do the
Right.
release numbers, but I'm pretty sure I used release 19 or 20, and it may have been the hardest thing I've ever done.
Yeah, super powerful.
Crazy.
But oh my goodness, is it difficult to use?
Yeah, but it's amazing because like the dude that taught me how to use it, he was like pew pew pew
Right,
pew,
right,
and like,
shooting lasers.
It was crazy how fast he could make something, and how it made total sense when I watched him.
Yeah.
But when I tried to do what he did, it just didn't work.
Yeah, and I think their stronghold is really like with the government, like big companies like that, big contractors. I think they just have like a lot of seats of that software still, and that's how they stick
And I think
around.
what happened was because PTC was the first one in the market, they
got
gained
their foot in the
all
door,
this market
yeah.
share. Because if you look at them nowadays, they really focus on like wind chill and data management and
Right.
kind of back end processes. I mean, they do have the Creo family of
do.
products
CAD
now,
design.
but they seem to really be focusing on like the management of the data and kind of taking it up a level, and not as much on the 3D CAD side. Just my opinion. Could
Right.
be totally wrong.
So this stuff, the old stuff in '87, only ran on Unix. Is that right?
Originally, yes.
Originally
and
only
then
ran on
I
Unix.
think it was sometime around 93 or 94 is whenever
Okay.
PTC moved over to
Oh, okay.
like an IBM style computer.
All right, makes sense.
Okay, next up. And this is a big window.
Yeah, there's a large gap in here.
95, who was it?
SolidWorks.
SolidWorks. So we're talking like, what is that, 10, not 10, 8 years,
8
9
years,
years,
yeah.
something like that, 7 years between PTC and the next major player in 3D. So SolidWorks in 1995 launched the very first version of SolidWorks.
And let's be honest, in the manufacturing space still, SolidWorks is,
Probably dominant.
majority shareholder for companies using the software. Really good tool.
Yeah, now, it's interesting. So right after that, so 1996,
Oh, goodness.
can you take a guess what it was called?
96?
Oh, you don't have this
I
one?
don't have this one. I mean,
Okay.
I could take a guess as to what happened, but I'll let you go ahead and have this one.
So Autodesk
There we go.
decided that they needed to have something to go after this
Right.
3D market, because they had the 2D market pretty well locked up, and they still do for the most part with AutoCAD.
AutoCAD's still a mere, what, like $1 or $2 a year product?
And I think that's just like the legal stuff. I'm sure
I don't
those,
wanna
like,
know
the
about the
people,
pirated
yeah,
stuff.
the pirated
Holy
stuff
cow.
probably off the chart. So
Yeah.
1996, Mechanical Desktop launched, and this was supposed to compete with SolidWorks
Right.
and PTC. It didn't do all that well. But it's interesting how just those couple of year window
Yeah.
between that and Mechanical Desktop, and then in in 1999, the next, I'll say, major player in 3D CAD, you got this one, I'm
No,
sure,
go ahead. Keep going.
is Autodesk Inventor.
There we go.
So this basically replaced Mechanical Desktop, because Mechanical Desktop was essentially AutoCAD with a whole bunch of these different plugins and all these different acquisitions, at least the way I understand it, making Mechanical Desktop. So it wasn't really built from the ground up. It was all these different things kind of plugged together to do it. So then in 1999...
Hold on. Let me interrupt. Well, go ahead. Finish your 99, and then I'll jump in.
So in 99, Inventor launches, and it runs parallel with Mechanical Desktop at the same time for about 3 years.
Okay.
And ultimately they transitioned over, and those are the big players in 2D and 3D to this day, I think.
Okay, so let's backtrack a little bit.
Okay,
because
good.
I think there's a lot of fun to be had with SolidWorks.
Backtrack. I do too.
So back in 1995, they come together and build this great 3D
Boston,
CAD, Boston area, somewhere
Okay.
up there. And Autodesk, who has AutoCAD and is ruling all of 2D, says, "Yep, that 3D is a great idea." let's just make our own.
Did they have the opportunity to buy SolidWorks
They had the
at one point?
opportunity to buy SolidWorks, which I think that decision may have come back to bite them a little bit.
Well,
which, that's fine. I
that
mean, Inventor's
happens.
good too, so that's great. But another fun thing about the SolidWorks guys, do you know where, at least this is my understanding of where the initial money came from to get this thing spun up? One of the guys involved was involved with that counting cards thing.
No.
What is it? 21?
Yeah,
that
the movie
21. He was one of those people. So he had just gobs of ill-gotten gains.
No.
That's what.
That's got to be like.
That's what I heard. Is
folklore.
Well, this is what I heard. Is that he had that he had that, and that's where they got their initial money to start running.
Wow.
So more power to him, because obviously he was a smart guy and an MIT guy.
So SolidWorks is blood money?
I wouldn't go
Is
that
that
far.
what that's called whenever you count cards?
I don't think
it's
so.
It's not called blood money?
I don't think so.
Not blood diamonds or anything like that?
No.
Okay.
But anyways, then in 97, Dassault Systems acquired SolidWorks and gave all of those guys all sorts of money to go roll around
So what's
in.
the big dog for Dassault? What's their...
I think SolidWorks is their big thing.
Well,
But
no.
they also have products like Abacus.
Oh, they got
on
NX.
Oh,
No,
NX.
not
Did they?
NX. No, not NX.
I don't know.
I should know this.
I don't know what else they have, but maybe we'll come to it later.
Maybe we will.
Okay.
So the interesting thing about a lot of this is if you look at the seats sold, so even to today, so this is the last major release of a desktop 3D CAD system was in 1999 with Inventor. And even to today, just because they were first, they were bigger. So PTC has the biggest sharehold, then SolidWorks, and I think PTC's is a lot of
still
it's
is.
legacy.
Yeah, well, right.
It's definitely legacy.
Interesting.
But PTC, SolidWorks, and then Inventor rolls in third place.
Okay, well, that's interesting.
So, yeah.
All right.
Just throwing that out there.
So after all this, in the
all this.
late 90s, basically 4 big players left, right? Autodesk, Dassault, PTC, and then UGS, which is now Siemens, or Siemens PLM.
They're the NX guys.
They're
That's
the
right.
NX, yeah.
That's right. That's
And
right.
they also have Solid Edge, which is fine. And I have a game right at the end of this that I want to play with you. So let's bust through. I don't know how much you have left, but I have just a little bit to go.
I don't have much left.
Okay.
Actually, at all.
Okay, so let me finish this thing up. So the last couple decades, let's say, we've been rolling into where CAD and CAM all fits in one system.
Yep.
So a lot of the times you'd model in 3D, then you'd export it to a CAM system, or you'd export it to
Seems inefficient.
to a finite element analysis system or something like that. And now we're getting to a point where, like, Inventor has simulation and CAM inside of it, and SolidWorks has simulation and CAM inside of it, and basically and rendering and all these things are getting added into one platform, so you can do all of your work in one single space. But something I thought was interesting is even products like ANSYS, which is leader in the finite element analysis, computational fluid dynamics
Pittsburgh-based,
space.
right?
Pittsburgh-based.
Nice.
Canonsburg?
Canonsburg.
Canonsburg. They went out and bought SpaceClaim to have basically their own CAD package, and then you can use that to simplify your models and get them ready for FEA.
So you got a big FEA player trying to get into the. I don't know if
I don't think they're trying to get into that so much as having their own set product for their customers to use for.
Because it probably makes it
simplifying.
easier, so they can
have
more
a tighter
consistent.
integration,
Yeah, they can more
right.
consistently bring the geometry into ANSYS if they know the system it's coming from a little
Right.
more in depth.
And then the last thing I wanted to talk about is like the last 5-7 years or so is people transitioning to the cloud.
I'm excited about this one.
The cloud
Are
seems
you?
like, yeah, I think so. I like it. I think it's the way of the future and going to make things more powerful and easier and convenient. But, there's some bumps along the road. So
Yeah.
right now, Autodesk, who has Inventor, also has Autodesk Fusion 360, which is a CAD, CAM, SIM, everything
Rendering,
platform.
everything you want.
All in the cloud-based, which is pretty cool. And it's like super affordable and it's lovely. But also, there's another product out there, Onshape, that is
Same basic concept,
the same
right?
basic concept, but it's made by the people who originally made SolidWorks, which I think is interesting.
Yeah, I remember when that cat left SolidWorks. He retired.
He retired
And-
conveniently made this.
And got a ton of money. And then, like, I think it was like a year later is whenever Onshape launched.
I don't know.
I remember that transition. It was an interesting one.
All right, so that's all I have for cloud. It's still coming, you know. Do you have anything to add about the cloud?
No, the thing I think
Because I have a
that's-
fun game I want to play with you.
No, the only thing I want to say about the cloud is I think that a cloud-based CAD, I think it's going to be a really similar transition to when people went from 2D to 3D.
Yeah.
I think it's going to be a little bit longer, and the only reason I say that is because there's intellectual property issues with stuff being in the cloud.
Yeah.
There's capacity issues, but you got things like Amazon Web Services running all this stuff in the cloud. It's like instantaneous how
It is.
fast stuff is happening. So I think it's going to be an easy transition, but I think it might be a little bit longer than just saying, oh, this is a new project, I'm going to do it in 3D.
I think once people get over like the intellectual property issues and things
Yeah.
like that, they're going to see just such a big advantage to doing things in the
'Cause
cloud.
everybody puts their personal information online, and,
do.
and that level of security that you have for that, I think, is way higher for the stuff that like Amazon Web Services
Right.
is doing. So, yeah, I'm looking forward to it. I'm excited.
So a fun game to wrap this up,
go.
Luke.
I'm ready.
Have you used? That's the name of the game. Have you used
I totally forgot all the hardware
the
stuff I was going to
following?
talk about. We ran out of
that's
time.
Okay. The following CAD packages: a Libre,
Yes.
Autodesk Inventor,
Yes.
Autodesk Fusion 360,
Yes.
Autodesk Mechanical Desktop,
Yes.
AutoCAD,
Yes.
in any of its various forms, SolidWorks,
Yes.
Solid Edge,
Yes.
Space Claim,
Yes.
Onshape,
Yes.
IronCAD,
No.
Pro E, any
Yes.
of them, Key Creator,
No.
CAD Key. They're the same product. So
No.
probably not. CATIA,
Yes.
Siemens NX.
Yes.
Oh, I've never used that one. Bentley's MicroStation.
Yes.
Have you?
Yeah.
Ooh, I bet that's difficult. Google SketchUp.
Yes.
All right, that's pretty good. So those are what the ones I picked out.
How many of those have you used?
I have used all of them except MicroStation, NX, and
You never used MicroStation?
no. Those are the only two I haven't used.
Okay, so we're right in the
Yeah,
same.
we're in the same
Even
ballpark.
though I'm far more mature,
Mature.
we'll say mature rather than older than you. You and I have similar experiences with the software. I
That
think.
is correct. I might not have used them
Okay,
as often.
if
but
you had, okay, this is another one. You might
I
not want
can't
to
answer
it.
this. No.
What's your
Don't-
favorite?
Nope, don't answer
What's
that.
your favorite?
I like them all equally.
Oh, you are the worst.
What's your favorite?
So it's what you learned
what you
first,
learned.
I think, is what determines your favorite.
Okay.
So I learned AutoCAD very first. That's my favorite 2D, and Inventor was my first 3D package I learned. So that's my favorite.
I shall plead the fifth. And with that, do you want to give a shout out to our event coming up since it's
Yeah.
very fitting for this?
Oh my goodness, super excited about this. So, so James and I in Unprofessional Engineering have been invited to Autodesk University this year to do some live podcasting. So we're going to be doing a number of podcasts. So this is the week before Thanksgiving. So if you're at AU, make sure you stop by and see us. If you're not going to be at AU, we're going to bring AU to you via the
Us.
podcast.
Oh, we are good.
And it's going to be super exciting. I can't wait. We're going to be doing probably at least 3 a day, probably Tuesday, Wednesday, Thursday is my guess.
I think that was the plan.
As soon as we have the schedule, we'll start sharing some of the information. But it's going to be super exciting. We'll be interviewing different executives at Autodesk to find out some of the direction that Autodesk is going with some of their technologies. We're going to be talking to some customers at AU that are using some of the Autodesk products and in different industries. And it's not just going to be manufacturing. Hopefully, we can actually talk to folks across all different aspects of industry, whether it's AEC or CNC or all these other.
Remind me if we ever
acronyms.
get a sponsor not to have you do the reading. It will be
Why?
the whole episode.
I'm the. You're so mean to me sometimes.
I am. I'm sorry.
Your mother is going
She
to yell
is
at
going to
you
yell
for
at
the
me
way you
again.
just treated me.
I know. She does every week.
I'm done now.
All right. With that, thanks for listening, and we'll see you again next week.
See ya. There we go. That was. What are you
Are we
talking?
done?
I thought that was good.
It was good.
Don't hit delete video when you do this. Hit done. Camtasia.